Hello there, kiddos, and welcome to our first videoed lesson. We are starting officially to start curriculum today, and your first set of notes are based on our first lesson. We are going to be spending a lot of time with formatting in your composition notebook. You learned yesterday in class, or earlier today in class, how to set your notebook up, and we are now going to start writing our first lesson's worth of notes. When we start a module, which we are doing today, we write the module number and the name of that module up here at the very top. And then right underneath it on this first line, we write the name of the first actual lesson. So we're going to go ahead and do that right now, and I'm going to teach you how to do that. So I need everybody to write up near the top of the paper, so Module 1, because we're starting with the very first module, and the name of this module is called Ratios and Unit Rates. So we need to write ratios and unit rates up at the top. Okay? And that's the name of the whole entire module. Okay? The name of today's lesson is a little bit different, and it is just the word ratios. So lesson 1 is called ratios. Pretty simple. So you need to write that title, and every time we change a lesson, so tomorrow when you take notes, we will not write this again. We will just write the new title, and the new title always sits on the top line. Okay? So there's our first word of our lesson for today. The next thing that we also include in our notes so that you can remember this and so that if anybody asks you what you're supposed to be learning, that we have a guiding goal for the lesson, and we also have a guiding question. So our guiding goal for this lesson, or our goal for all of our lessons, we're going to write that right here. So you're going to write goal. Our goal for today is, today we are going to learn about ratios and ratio relationships. So you need to write that. Today we are going to learn about ratios and ratio relationships. Okay? And don't worry if you don't know the format of our notes, because there's kind of no way that you could, because we've never been in class together before now. But I will get you, and you will get very used to the pattern or the layout of our notes. So we always put our title at the top, then we always write our goal so that we know what we're focusing on our learning today, and now we're going to include the question. So today we are going to learn about ratios and ratio relationships. And I'm hoping, boys and girls, that maybe you have some knowledge of this already. Maybe your 5th grade teachers gave you a little bit of help with this. But if not, that's my job, and so I will be helping you with it. Our question that we will be able to answer by the end of today's lesson is, what is the difference between a ratio and a ratio relationship? That's the question that you're going to be able to answer. So let's write it right here. What is the difference between a ratio and a ratio relationship? Okay? That's what we're focusing on in today's lesson. All right? So again, we will come back before the end of the lesson today and tomorrow, and you will be able to answer that question. All right. We do have a task, and a task is a way for us to focus our energies and our thoughts in working with this question and this goal for today. The task is, the co-ed soccer team has 4 times as many boys on it as it has girls. We say the ratio of the number of boys to the number of girls on the team is 4 to 1. We read this 4 to 1. So I need you guys to write down this task, because we are going to be using the 3 read strategies that we learned today in class to help us answer some information about it. So please write the task with me. the co-ed soccer team has 4 times as many boys on it as girls. Okay, so that means that there are 4 times the number of boys as there are girls. We say the ratio of the number of boys to the number of girls on the team is 4 to 1. Okay, when we have that written, we read it. We read this as 4 to 1. That's how we read it. Okay, so you have just written down your first example of a ratio. Okay, now thinking about our 3-read strategy, what is the first read? What do we do with the first read? Okay, remembering back, the first read is what is the task about? Okay, so let's read it one more time. The co-ed soccer team has 4 times as many boys on it as girls. We say the ratio of the number of boys to the number of girls on the team is 4 to 1. We read this as 4 to 1. So, boys and girls, what is this task about? The task is about the ratio of boys on the team to girls on the team is 4 to 1. Okay, so again, using the 3-read strategy, we now need to do our second read, and remembering from earlier today that the second read is where you're looking for the quantities. So what are the quantities in the task? So again, remember, it says second read. So what does that mean that you have to do? You have to read it again. The co-ed soccer team has 4 times as many boys on it as girls. We say the ratio of the number of boys to the number of girls on the team is 4 to 1. We read this as 4 to 1. Do you think you could make a table of the quantities? I think we can. So let's do that. Let's make a table of the quantities. Okay, and we're going to do a horizontal table, and it looks like this. We need 3 slots. Okay, and in the first slot, you're going to put number of boys, and in the second slot, you're going to put number of girls, and then in the last one, you're going to put total number of players. Right? And that's how we're going to build our table. So let's go back because I think we've got it, but I want to make sure that we know the number of boys in there. If it says the co-ed soccer team has 4 times as many boys on it as girls. We say the ratio of number of boys to the number of girls is 4. So every 4 boys on the soccer team, there is 1 girl. So the number of boys is what? The number of girls is what? The total number of players is what? So the number of boys is 4. The number of girls is 1. The total number of players is 5. Okay? Hopefully all of you understand that. Everybody's paying attention. Okay? And we now have to do our third read. Okay? And our third read is trying to find the relationship of the quantities. Remember what the quantities are? The number of has a number with a unit, so we have 4 boys for every 1 girl. So the third read is, what is the relationship of the quantities? Okay, so if we go back and read it one more time, the co-ed soccer team has 4 times as many boys on it as girls. We say the ratio of the number of boys to the number of girls on the team is 4 to 1. We read this as 4 to 1. So what is the relationship? I would like you to come up with the relationship between the number of boy players and the number of girl players on the team. That will be your first question that you have to answer for checking while I do an ETL check tomorrow morning. So I'm going to let you figure out what is the relationship of quantities between the number of boys and the number of girls. Okay? All right. So once you've got that down, the next thing that we need to look at for this lesson is, based on your answer to that question, do you think that the ratio of boys on the soccer team to the number of girls on the soccer team is big enough to make a team? Do you think that ratio is giving us enough children to play soccer? Okay, so we need to write that down. Is the ratio of boys on the soccer team to girls on the soccer team big enough to make a team? Okay, it says for every 4 boys there is 1 girl, which makes how many players? 5 players. Is that enough to make a soccer team? I'm not sure. I think so, but I don't know for sure. Let's make a table. Let's make a table to show some more team sizes. With the ratio of 4 to 1. Okay, so again, remember what we did when we made the table. We had the number of boys, the number of girls, and the total number of players. So number of boys, number of girls, total number of players. All right, so if we have for every 4 boys, there is 1 girl, that makes 5 players. What if we have 8 boys? Your job for tomorrow is to tell me how many girls you would have and what would be the total number of players that you had. And then the last one that I want you to try is, what if you had 3 girls? How many boys would you have and how many total players would there be? Okay, that's your job between now and tomorrow when you come to class to have the answers to those tables filled in. Okay, now my next question is, what happens if we change the ratio? Okay, what would happen if we change the ratio of the number of boys to the number of girls? Would that change what we have? So let's say that this time, instead of having a ratio of 4 to 1, let's say that our new ratio is 3 to 2. Will we have the same number of players? I don't know. I think you should make another table and find out. Okay, so we're going to make another table. And again, we're doing number of boys, number of girls, and total number of players. And boys and girls, in this ratio above, it is still boys to girls. So this ratio would be boys to girls ratio of 3 to 2. So again, fill in your table. For every 3 boys, there are 2 girls. What are the total number of players? Aha! Again, we get that. Interesting. Okay? What if this time I tell you there are 4 girls? You need to figure out what the number of boys and the total players would be. And what if I tell you that there are 9 boys? You need to figure out the number of girls and the number of total players there would be. Okay? All right. So then the next thing that we have is what if the ratio of boys on the team to the girls on the team was 3 to 2? And how could we figure out if what the boys would be if there's only 1 girl? That looks a little bit scary. So let's try that. If there was only 1 girl, could you figure it out? All right. And I'm going to say in these notes that if you can't figure it out without me, that's okay. But we're going to talk about it right now, and I'm going to show you something that may help you figure this out and make it a little bit easier. And the thing that we do sometimes is we use pictures to help us. Okay, so we know how to make a table, and now we're going to talk about it as if it were pictures. Okay, so one of our mathematical practices is to use models in mathematics, and one of the models that we can use is a thing called a pictograph. So if we could use a pictograph to help us figure it out, that would be helpful. So let's draw using pictures. So we know that our boys, so we're going to put a model to help us, a model to help us. All right, so let's try it. So we have boys and we have girls, right? Okay, and we learned that when there were 3 boys, so I'm going to use rectangles for the boys. So when we have 3 boys, right, how many girls are there? There are 2 girls. So I'm going to use triangles for girls. I don't know why, because girls can wear dresses. I don't know. Okay, so for every 3 boys, there are 2 girls. Well, what would we do if we only had 1 girl? So what you've got to think about on here is you've got to think, how, right now I have 3 to 2, right? So I'm trying to figure out how to get it so that there's only one girl. So how can I get from 2 to 1? What could I do to the 2 to get me 1? I could divide by 2, yeah? Okay, because 2 divided by 2 is 1. Well, the rule in math is what you do to one side, you have to do to the other. So if I take 2 divided by 2, I also have to take 3 divided by 2. And 3 divided by 2 gives me what, everybody? It gives me 1 1/2. Okay? So what that means is for every 1 girl, there are 1 1/2 boys. I know. How can you have a half of a boy? But that is mathematically how the ratio works. For every 1 girl, there are 1 1/2 boys. For every 2 girls, there are 3 boys. That's how we figure it out. Okay? This kind of model with these pictures is called a pictograph. There is another way to do it that's a little bit more helpful and I like better because we're in math, and it's the use of tape diagrams, which you're going to learn a lot about this year. So we have boys to girls, and a tape diagram is exactly what it sounds like. It's a piece of tape that we rip off a roll, and then we divide the tape into equal parts. So we know that there are 3 boys. So I have to take this piece of tape and make it 3 equal parts as best as I can. So the sizes have to be the same. Now, is the piece of tape for girls going to be the same length as the piece of tape for boys? The answer is no, because we don't have 3 girls. We have 2 girls. So I have to make my piece of tape the same size as only 2. And then you can see that that is our ratio. For every 3 boys, we have 2 girls. So now the question again, we're trying to figure out what it would be for 1. So we have to take this guy, this piece of tape, and we have to show what it would look like if there was only 1 girl. Well, we know we're going to have at least 1 boy because we did the math up above. So here's my 1 girl, right? So we know we have at least 1 boy, but what do we have left? Half of another boy, yes? So here would be a whole nother piece, but we only have this much, right? And so that's how you would show it with the tape, okay? And so we have for every 1 girl, there's 1 1/2 boys, and that's using a piece of tape to help us. So this one right here, if we color in what we have, for every 3 boys, there are 2 girls. For every 1 girl, there are 1 1/2 boys. So hopefully that picture can help you understand it a little bit more. And again, just to label it so we know what these are, these right here are called pictographs. And these right here are called tape diagrams. And remember, a diagram is a picture or a representation, and it's built out of tape. So that's what a tape diagram is. Okay? All right. So that gives us a picture, and were we able to figure out how many boys there would be if there was only 1 girl? Yes, we were, and the answer to that is 1 1/2 boys. So we have 1 1/2 boys for every 1 girl, which would give us 2 1/2 players. That's kind of funny, and it's kind of silly because I don't think you can have 2 1/2 players, but mathematically, that's what we were trying to find. Okay, so now our next idea that we have to figure out is what makes something a quantity. Okay, we talked about that a little bit yesterday when we were working with our notes, and so what makes something a quantity? Let's figure that out right now. What makes something a quantity? There were three things. Do you remember it from yesterday? Okay, number one, it has to be a number. Okay, can a number by itself be a quantity? No. Number two, it has to be positive or negative. And then the third thing that you must have, remember we're talking about a quantity, is it has to have a unit. Okay, so those are the three things that makes it a quantity. Okay, a ratio, so looking at these right here, like remember we've been talking about that this is a ratio right here. A ratio is not a quantity. Why isn't it a quantity? Okay, we need to know why that is. A ratio is not a quantity. Is there anybody who knows why? Okay, a ratio is not a quantity. And the reason why is a ratio is not a quantity because it only has a number. Okay, and remember we talked about the three things that it had to have. A number, positive or negative, and a unit. Okay, a ratio, 4:1, like this one right here, does not have a unit of measure, so it is not considered a quantity. Okay, a ratio relationship, so we're talking about a ratio here. A ratio relationship, however, a ratio relationship has words that describe the ratio, so it is a quantity. So this is kind of interesting information. A ratio is just a number. A ratio relationship is actually a quantity. Okay? And so we need to understand the difference between, oh, wait a minute. If we go back to our question, what is the difference between a ratio and a ratio relationship? A ratio only has a number. A ratio relationship has words that describe the ratio, so it's also known as a quantity. So let's make a little guide to help us keep this straight, because I know this is a lot of information and it feels a little bit confusing. When you get in class tomorrow, it won't feel so confusing. But an example of a ratio would be 3:2 or 7:3, because remember we can write it with a colon or we can write it with the words. A ratio relationship, however, has to have words that describe it, right? And so this one is not, but we have to make this one. So a ratio relationship that we could write for this one is for every 3 gallons, you can travel 20 miles. Okay, so now this is a ratio relationship because it has the words describing the ratio. So 3 gallons, for every 3 gallons, there are 20 miles driven. Okay, or you can go 20 miles. For every 7 minutes of homework, you can complete 3 math problems. So that's another ratio relationship. For every 7 minutes, you can complete 3 math problems. Okay? So that's the difference. The relationship has words that describe it, whereas the ratio itself is just numbers. Okay? So now we are to my favorite part of our notes, and that's where you actually get to try this whole process on your own. and we call it the Let's Try It section. And so I have two things that I need you to do before we come to class tomorrow, and you need to do this in your notes. And so the two things that I want you to do to practice this are, first of all, I would like you, let's put our title in there, Let's Try It, okay? And I want you to write a ratio, be careful of the words, write a ratio for the number of pets to people, oops, I should write what I say, the number of pets to people in your house. Okay, that's the first thing you have to do. Write a ratio for the number of pets to people in your house. Okay, and then the second thing that you have to do is, dun, da, 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 write a ratio relationship, a ratio relationship for these ratios, and I'm going to give them to you in just a second, okay? And the three different ratio relationships that I need you to show me is, give me a ratio relationship for 12 to 1. I would like a ratio relationship for 5 to 7, okay? And the last one that I want you to do is I would like you to write a ratio relationship of 1 to 2. I know, that's kind of easy. All right, a ratio relationship. So the practice that you're going to do is the ratio for the number of pets to people in your house, and then a ratio relationship for these three different things. Okay? So going back to our goal, I know this was a bit of notes, but I think you guys did a pretty good job. Today we are going to learn about ratios and ratio relationships. Hopefully you're feeling pretty good about that. The question is, what is the difference between a ratio and a ratio relationship? I think you guys probably have got it. I want you to go back through your notes now and see any blanks that we left, filling in the tables, then answering these two Let's Try It. I think there was one other where you were supposed to tell me what is the relationship of the quantities in the task, so don't forget to get those done. And nice job on your first